Okay, our next video is about the standardized approach. So everything we've talked about so far about regression has been focused on the raw values or the observed metrics for X and Y. But as many of you know, when you run regression in SPSS or SAS, you're going to get standardized results, and APA requires, I think they require, although I'm not sure whether the new publication manual requires this, but many publications, many journals require that you report standardized regression coefficients. And since everything we've talked about are B's, or unstandardized regression coefficients, and that is B and A, are both in the metric of Y, as I described in the previous video. But suppose we want to get standardized coefficients. What we need to do in R is, because R only deals with unstandardized coefficients, we need to change X and Y in such a way that it knows that X and Y are both standardized, so therefore the coefficient will be a standardized or metric-free coefficient. And in addition, we know that when we have a standardized solution, we don't need the intercept. So here what we have is we have a linear model where we have scale y and tilde scale x. So this is our dependent variable, scale y. And scale is a function in R that just standardizes the variable. So I scale y and then scale x, and then -1 tells me, it tells R that I don't want the intercept. I renamed this linear model LM2 because I want to differentiate it from LM1. And as you'll see shortly, I'm going to run all this code together. It's basically the same thing. I've run it this way, where I scaled it within the linear model, and here where I did YZ and XZ and then created an LM2, I just overwrote this object, where I have LM is YZ tilde XZ -1. Both LM2s produce the same result. I just wanted to show you this, but the reason why I wanted YZ and XZ is so I could plot them. And the plot looks like, whoop, there we go. This is what the plot looks like. So you notice that the data points look pretty much the same. They don't differ a whole lot. The slope of the line looks pretty much the same. Everything is represented pretty much the same way that we saw before, except the metric of X and Y are now standardized. And as you see, this is 0 for Y and this is 0 for X, and you'll notice that the line of best fit goes through the origin, and it must, because that's what it's doing. When you're standardizing, you're centering on the mean, and when you center on both the mean of X and the mean of Y, the regression solution, remember that we find out A by looking at the mean of X and the mean of Y, right? We compute that after we calculate B. So therefore, the logic stands that the X or the Y intercept when X equals 0 is going to be 0. So it's all centered. It's now centered on the means, on both means, and therefore there's no intercept to estimate. So that's why we put a -1 in there. And now we have a metricless predictor and a metricless dependent variable. And that's what standardizing is all about. But let's do a summary of LM2 so you can see what I'm talking about. I'm going to scroll through all that. I already ran it before. And now we get the output that looks pretty much the same, but now we have XZ, and the estimate is 0.5052. It's a lot of significant digits, but that's okay. If I did the correlation between XZ and YZ, we'd get the same result, because it's 0.51, and it's 0.51 for the correlation. And that's precisely what we're getting from beta. So instead of B, now we're getting beta, but R doesn't know any better. R treats this as a B, because it is a B. It just so happens to be a B between two standardized variables. And therefore, when you have standardized predictors and a standardized outcome, you are going to have betas. And the betas, the B's, are just now interpreted as betas, and they range between -1 and 1. 0 meaning that they have no predictive capacity, whereas our b's before were in the metric of y over x. So if you had different metrics, wildly different metrics, like predictors of GPA, or if you had GPA as a predictor and the dependent variable was yearly income in dollars, well, hopefully you're making 50, 60, 70,000 dollars, big numbers, and that your predictor values are going to be teeny tiny, like 3 point something, maybe 4. So that will affect the B's, but the betas are not affected at all. They just reflect and can be compared with one another because they're in standardized coefficient units. And that's the way we interpret betas, and this is the way you do it in R. In SPSS and SAS, they're produced by default, I believe. Actually, in SAS, you have to put STB for standardized B's. And this is the way you interpret B's versus betas. But in R, it does everything explicitly. So this is the end of the material that I want to cover. And following this, I want to give some examples and then provide a little bit of an idea about other applications and purposes of regression. So stay tuned for the next videos.